Download this code from codegive.com, link in the description below. Python Overflowerror and Math Range Errors, a comprehensive guide. Python, being a dynamically typed and high-level language, handles many low-level details behind the scenes. However, certain numerical operations can still lead to errors like overflowerror and mathrangeerror, indicating issues with the range or validity of the calculations. Understanding these errors, their causes, and how to handle them is crucial for writing robust and reliable Python code. 1. Overflowerror. 1.1. What is overflowerror? Overflowerror is a type of exception raised in Python when a calculation exceeds the maximum representable value for a numeric type. Essentially, it means the result of a mathematical operation is too large for Python to store within the available memory allocated for that data type. 1.2. When does overflowerror occur? Overflowerror most commonly occurs in the following scenarios. Asterisk integer overflow, Python 2. In Python 2, the int type has a limited range. When an operation involving integers results in a value larger than the maximum int can hold, an overflowerror is raised. This issue is largely mitigated in Python 3. Asterisk floating point overflow asterisk while floating point numbers, type float, have a much wider range than integers, they can still overflow when calculations yield extremely large values. However, instead of raising an overflowerror, floating point overflows typically result in INF, infinity, being assigned to the variable, or INF for negative overflows. This is because Python's float type conforms to the IEEE 754 standard, which defines INF as a valid floating point value representing infinity. Asterisk complex number overflow asterisk complex numbers are also susceptible to overflow if their real or imaginary components become too large. Similar to floats, a complex number might transition to a value containing INF in its real or imaginary parts instead of directly raising overflowerror. 1.3. Python 2 versus Python 3 and overflowerror. The most significant difference regarding overflowerror between Python 2 and Python 3 is the way integers are handled. Asterisk Python 2 asterisk there are two integer types, int, fixed precision integer, and long, arbitrary precision integer. Overflowerror occurs when an integer operation exceeds the range of the int type. You'd often have to explicitly use long to handle very large numbers and avoid overflowerror. Asterisk Python 3 asterisk Python 3 unifies the int and long types into a single int type that supports arbitrary precision arithmetic. This means that Python 3 can handle very large integers without raising overflowerror, as it dynamically allocates more memory as needed. If you create very large numbers, you will eventually run out of memory, but mathrangeerror will be thrown instead of overflowerror. 1.4. Code examples. Python 2 example, illustrating overflowerror. Python 3 example, no overflowerror. Floating point overflow example, Python 2 and 3. 1.5. Handling overflowerror. Asterisk exception handling, try, except wrap the potentially overflowing code in a try, except block to catch the overflowerror and handle it gracefully. Asterisk using arbitrary precision arithmetic, Python 3 in Python 3, use the built-in int type, which automatically handles arbitrarily large integers, making overflowerror less common for integers. Asterisk checking input values asterisk before performing calculations, validate input values to ensure they are within reasonable ranges and will not lead to overflow. Asterisk using libraries for big numbers asterisk if you need to perform precise calculations with extremely large numbers, consider using external libraries like Decimal or GMPy2. The decimal module is particularly good for calculations where precision is very important, example financial calculations, and GMPY2 offers much faster arbitrary precision arithmetic compared to the built-in int. Re-evaluate your approach. Could a different calculation or algorithm prevent such a large overflow? Example of handling with try, except *. 2. Math range error, value error or other exceptions depending on context. 2.1. What is a math range error? A math range error is a more general concept than overflowerror. It describes a situation where a mathematical function receives an input that is outside the valid domain or range of that function. Python usually raises a value error or sometimes other exceptions, depending on the specific function and the nature of the invalid input. It's about providing mathematically invalid inputs, rather than exceeding memory limitations. 2.2. Common scenarios for math range errors. Square root of a negative number. Attempting to calculate the square root of a negative number using math.sqrt raises a value error because the square root function is generally defined only for non-negative real numbers. Logarithm of a non-positive number. The logarithm function, example math.log, is only defined for positive numbers. Providing a zero or negative argument will raise a value error. Trigonometric functions with invalid inputs. Some trigonometric functions have restricted domains. For example, math.asine, and math.acos, arcsine and arccosine, are only defined for values between -1 and 1, inclusive. Passing values outside this range will result in a value error. Division by zero. While not strictly a range error, division by zero results in a zero division error, which falls under the broader category of invalid mathematical operations. Factorial of a negative number or non-integer. The factorial function, math.factorial, is defined only for non-negative integers. Providing a negative number or a non-integer argument will raise a value error. 2.3. Code examples. 2.4. Handling math range errors. Exception handling, try, except use try, except blocks to catch value error, zero division error, and any other relevant exceptions that may arise from invalid mathematical operations. Input validation. Validate input values before passing them to mathematical functions. Check if the input falls within the acceptable range or domain for the function. This is the most effective way to prevent these errors. Conditional statements. Use if statements to perform checks on input values and avoid calling the function altogether if the input is invalid. Using libraries with more robust error handling. Some libraries are designed to handle edge cases and invalid inputs more gracefully. For example, the NumPy library often returns nan, not a number, for invalid operations instead of raising an exception, allowing you to handle the situation programmatically. However, be aware that nan values can propagate through calculations and lead to unexpected results if not handled properly. Example of input validation. 3. General best practices to prevent and handle numerical errors. Understand the domain of functions. Thoroughly understand the valid input domains and ranges of the mathematical functions you are using. Consult the Python documentation or relevant library documentation. Validate inputs early. The earlier you validate inputs, the less likely you are to encounter errors later in your code. Use appropriate data types. Choose the appropriate data types, example int, float, decimal, complex, based on the expected range and precision of your numerical values. Document assumptions. Document any assumptions you make about the range and validity of your input data. This helps other developers, and yourself in the future, understand the code and avoid introducing errors. Write unit tests. Create comprehensive unit tests that cover various scenarios, including edge cases and potentially invalid inputs, to ensure your code handles errors gracefully. Monitor for numerical instability. In complex numerical algorithms, be aware of the potential for numerical instability and consider techniques to mitigate it, example scaling, regularization. Log errors and warnings. Log errors and warnings related to numerical issues to help with debugging and monitoring the performance of your code. 4. Conclusion. Overflowerror and math range errors, typically value error or other exceptions, are important considerations in Python programming, particularly when dealing with numerical calculations. By understanding the causes of these errors and implementing proper error handling and input validation techniques, you can write more robust, reliable, and maintainable Python code. Remember that proactive prevention is often better than reactive handling. Thoroughly understanding the mathematical context and validating inputs goes a long way towards avoiding these issues in the first place.